Okay, static Huffman coding. So this coding involves creating an unbalanced tree with some branches shorter than others. The degree of the imbalance is nothing but the function of relative frequency of occurrence of the characters. Here, the larger the spread, the more the unbalanced is the tree. So the resulting tree is known as Huffman code tree. Okay. So we are using the static Huffman coding to code the for textual characters. So how to code that can be done by using the static Huffman coding. So here, what is Huffman coding? Huffman tree ಅಂತ ಅಂದ್ರೆ Huffman tree is a binary tree with the branches assigned as a value 0 or 1. Okay. The base of the tree is known as a root node. The point at which the branch divides, it is called as a branch node. Okay. And the termination point of the branch is known as a leaf node. Okay. So this is, you should know, a Huffman tree. It is consist of a binary tree with the branches assigned value as 0 or 1. Okay. Here base is known as a root node and the point at which the branch divides is known as a branch node. Okay. The termination point of the branch is known as a leaf node. Okay. So this is, you can see in this diagram. Okay. You can see here the root node. This is called as root node, starting point of the tree. It is called as root node and it is divided by two branches. So it is called as branch node. So we have assigned 0 and 1 as a binary values. Okay, this is the first step in the Huffman tree. If you want to learn the static Huffman coding, first you have to know the Huffman tree. So Huffman tree is nothing but Huffman is a scientist name. Okay, Huffman tree. So he has the derived this coding technique. That is why it is called as Huffman tree. Okay. So here, so I have taken one example. This is A, B, 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 C, D. One example I have taken. Okay. So using this example, I'm just demonstrate this coding operation. How to derive the Huffman coding tree and the codes for the characters. Okay. So in this diagram, so as I told earlier, this is called as root node and these two are the branches and assigned as a 0 and 1. Always remember, left side of the branch is assigned as 0, right hand side branch is assigned as 1. Okay. So next, again it will continuously dividing with each other. Okay. So we have 1, 2, 3, 4. 4 characters are there. Okay. So 4 characters are there. So that is why it is divided. We have 1, 2, 3, 4, no, 4 leaf nodes. So 4 leaf nodes is nothing but we have 4 characters. So one root node we have. Okay, we have different branches. So this how many characters we have in the text, that number of the branches and the leaf node will come in the Huffman tree. Okay. Here branch node, it is divided here. Here also it is divided here. Okay. So left hand side is always assigned as a 0 binary value. Right hand side is always assigned as a binary 1 value. Okay. So what I have done here is, okay, root node I will write here. So I will divide two branches 0, 1. Okay. So last terminate point of the branch is called as a leaf node that has assigned as a ln is equal to a. Okay, ln is equal to a. So that is leaf node. Okay. Next, what I will do, again I will divide. Okay, again I will go for the left hand side. Okay, that is by 0, 0 side, 0 branch side. Again I will divide that for the next characters. So for next character is b. So I will take endpoint leaf node as a b and it is divided. So again I will assign 0, 1. Okay. Next. So next character is c. So again I will go back to the 0 branch. Again it will be divided. So at the one end it is assigned as a leaf node equal to c. Another end is, it is terminated. So no more extra characters other than the ABCD. That is why it is terminated. So it is C and D. So leaf node is C, leaf node is D. So all characters are, we have done the coding. We have drawn the tree diagram. A, B, C, D. 4 characters are there. A is repeating 4 times, B is repeating 2 times, C is 1 time, D is 1 time. So like that we have divided the tree. Okay, so this is the tree diagram writing procedure. Okay, so next, how to write the code for each characters A, B, C, D. Okay, so to write the code word for the characters, for example, I want to write for A character. Then what I will do? Then what I will do? I will take from root node to the leaf node. The value I will take from root node to the leaf node. See, in this example, leaf node is A. Okay, leaf node is A here. So for this I will go from top to the bottom. Top, that is nothing but root node to the leaf node. So root node here is I have assigned as a 1. So that is why these characters A is considered as a coding. It can be write as a is equal to 1. That means I'm going from top to the bottom, root node to the leaf node. So for a character I will write as a 1 as a code word. Okay, so like that I have written a for a is equal to 1 here. Next is uh, we have for B. So for B, what I will do? So again, I will go from the top to the bottom. That means root node to the leaf node. So from root node, I will go. So from root node, so we have 0 here, and I will come back to the leaf node. So 1 here. So I will write 0 from root node to the leaf node, 0 and 1. So that is why B has coded as 0, 1. Okay, so like that. For C, how can we write? For C, I can write as, again I will go back from root node to the leaf node. So root node is nothing but top node, leaf node is nothing but bottom node. So I will, while writing the code word for the character, I will go from top to the bottom. So top is nothing but root node. So we have 0 here. Again I will come back here 0, and I will come back here 1. So 0, 0, 1. So that is why I will write C character as 0, 0, 1 from top node to the leaf node. So root node to the leaf node. So 0, 0, 1. So how it is, the flow coming from top to the bottom, like that we need to write the code words. Next, for D character, how we can write for D character? I will go like this: 0 from top, 0, 0, 0. So flow, it is looking, we have to follow according to the flow. So from top to the bottom, okay, where it is, leaf node is located from root node. So 0, 0, 0. We cannot go like this 0, 1, like that. Okay, so we need to follow the procedure from top to the bottom, where it is the leaf node is terminated. So 0, 0, 1. So like that I have written 0, 0, 0. Okay, so this is about the one step operation of the static Huffman coding. So here Rn stands for root node, Bn stands for branch node, okay, and Ln stands for leaf node. Okay, this is one coding operation. So using this, we can reduce the set of codes associated with this tree. Okay, so how many bits are required for transmitting this number of the characters? So that can be seen by using this. Okay, here 4 is nothing but probability of occurrence of the characters. Okay, so 4 times a is repeating, that is why 4 into, next 1 is nothing but uh, code word for character A. So how many bits are there? 1 is there. That is why I will write 1 here. Plus 2. So B is repeating 2 times. Probability of occurrence of B is 2, or frequency of occurrence of B is 2. That is why 2 I will write into 2. So what is this 2? 2 is nothing but B. B is coded as 0, 1. So 2 bits are used here to code the B. So that is why 2 into 2. 2 times it is repeating B into 2 bits are used to code the B character, plus 1 into, so C is 1 time is repeating in the character set. So that is why I will write 1 here into 3. So 3 is nothing but number of the bits in the code C representation. Okay, so I will write 3 here because 0, 0, 1, 3 bits are there. That is why I will write 1 into 3 plus 1 into 3. How we can write like this? So 1 stands for, it is related to the D character. So frequency of occurrence of the D character is in the character set. We have one time it is repeating. Okay, only one time is it is appearing. So that is why I will take 1 here, 1 into 3. So 3 bits are used to represent the D character. That is why I will write 3. So if you do the calculation here, you will get 14 bits. So this is the set of the codes associated with the tree. Okay. So then we can analyze using this uh, pattern. Okay. To transmit the complete string A, B, B, C, D, we require 14 bits. Okay. Next, tree derivation. Okay, tree derivation, how we can derive the tree. Okay, so this is the one example how we can derive the same code words. Okay, same code words we will derive using tree derivation. Okay, so for that what I will do, so I will consider a b c d. First I will write a b c d. There are four characters in this a b b c d. A is one character, B is another character, C is another character, D is another character. Okay. So for that, I will write as it is, what is given in the string, complete string character set. I will write A, B, C, D. So A is 4 times it is repeating. Frequency of occurrence of the character in the string is 4 times. That is why I will write 4 here. Next, B is repeating 2 times. That is why it is 2 here. C is repeating 1 time. That is why it is 1 here. D is repeating one time. That is why we have 1 here. Okay. So this is called as frequency of occurrence of the numbers. What I have written in the beside the character set. A is 4, B is 2, C is 1, D is 1. Okay. So next, what I will do, I will assign the binary values. So as I done in the tree construction diagram, 0 is assigned as a 0 is assigned to left side, 1 is assigned to right side branch, right side branch. Here also, I will start from the bottom. So while writing the bottom tree derivation, so what I will do, I will assign 0 first, then I will assign 1. Okay, like that I will do. Okay, 0 first, then I will assign 1. Okay, so next what I will do, so I will calculate, see 1 plus 1 is 2. So value of 1 plus 1. Okay, frequency of occurrence of C and D. Sum I will take. So 1 plus 1 is 2 here. Okay, so 2 is similar to the next character value. So B is 2 now. Here sum is also we have 2. So in this tree derivation, we will go from bottom to the top end. So in the tree construction, we are coming from bottom top to the bottom. But in the tree derivation, I will go from bottom to the top level. Okay. So in this case, so what I will do, I will add these 1 plus 1. Okay. So I have assigned 0 for D, 1 for C. This is the binary assigning. Okay. Next, we have C equal to 1, D equal to 1. These values I'm going to add. So 1 plus 1 becomes 2 here. Okay. So 2 is similar to, it is same as the next higher level character value. So here also 2, here also 2. That is why I will this arrow marks I will keep here only. So whatever the arrow mark here we have, this I will keep here only, 2 and 2. Okay, this 2 is summation of value of C and value of D. So 1 plus 1, this is 2. This is the 2. That calculation value is 2. So both are equal. That is why I will kept the arrow mark here only, below the B only. If it is higher than the next character, if suppose if it is 3 means this arrow marks will go above the B. Okay, but in this case it is equal to B. That is why I will kept here below the B only. So 2 and 2 both are same here. Again for this I will assign 0 and 1. Okay, 0 is assigned below, 1 is assigned above. So this is completely repeating, okay, as like it finishes complete, it finishes, this is going to be repeat like this only, okay. So 0 again, 1 again, 1 as I have assigned. Again I will calculate this value, b value is 2, and we have summation of lower character set 2. So 2 plus 2 is again 4. So then again I will write arrow mark here. So I will write 4. Okay. Then this I will continue. So A4, A4 and A4. Okay. So 4 we have. Next higher character set is also 4 we have. Okay. So both are equal. That is why this arrow I am going to write below only. So that is why 4. So A4 and below 4. Okay. Again I will assign 0 and 1 binary value. So lower end, I will first lower side I will assign 0, and higher side I will assign 1. Okay. So this is called as tree derivation. Okay, using the frequency of occurrence and the character set. This is another tree derivation. So same code we will get at the end. Okay, we will see later. Okay. So what I will do? So for A4, for A4, for A4, so we have written 1 year. So we have written 1 year. Okay, starting at the leaf node. So if I want to write the starting at the leaf node, it is 1. Okay. So for B2, so for B2, I will write 1 0. So 1 0. So here 1 we have, 0 we have. So this arrow mark I have to follow. So for A I have written 1 here. So complete 1. So one binary bit is there. That is why I have written A4 is equal to 1. For B I will write this 1 and this 0. Okay. Next for C here we have C here, we have C here. So for that I will, what I will do, this is 1. So this 1 I will take, this 0 I will take, and again that arrow mark, whatever wherever it follows, you should follow the arrow mark while writing the codes. So 1 0 and arrow mark, it will go like this, and it is ending here 0. That is why 1 0 0. Okay. So like that for D also. So 0, so arrow mark is going like this, 0, arrow mark is going like this, 0. Okay, don't take the value of frequency of occurrence or summation of two characters, that you have to leave it while writing the codes. Okay, so you have to take the binary value 1 or 0, that's all. Okay, you need no need to take the some value and that particular character frequency of characters values. Okay, so like that you have to write. So this is called as starting at the leaf node. So 1 1 0, c 1 0 0 0 0 0. Okay. So finally what we will do, this is the starting at the leaf node. That means if you take the value from leaf node to the bottom node. Okay. If you take the value from root node to the leaf node, so it becomes reverse. Okay, so for that I will take reverse of this. Okay, so what I will take, so this one is 1 as it is. Okay, so this one is 1 as it is. Next, this 1 0 is written as 0 1 ulta, because if you want to take the code words for each character from bottom top to the bottom, okay, here in this in the starting at the leaf node, here we have taken from leaf node to the bottom, leaf node to the root node, or bottom node to the top node. Okay, if you want to take the value from top to bottom, okay, actually you need to take the value from top to bottom only. Okay, so that is why, so I will write ulta here. So a, this is one is written here. Next, so this 1 0 is written as a 0 1. Okay, this 1 0 0 is written as a 0 0 1, and this 0 0 0 is written as a 0 0 0. Okay, so reverse operation. So whatever the codes I have written for this ABCD in this step, it is written as a starting at the leaf node. I'm considering here as a starting at leaf node. That is why I have written like this. Okay, from um bottom to the top level. So here I have written from top to the bottom, top to the bottom. Okay, whatever I have shown in the tree construction, there also I have taken from top to the bottom. So you need to take that only from top to the bottom. So final, this is the final code words. So this is the one another method, yeah, that is taken from leaf node to the root node. Actual here is top to node to the bottom node or root node to the leaf node. So that is why I will take reverse of this. So here reverse operation I have done to write these code words. These code words here in this code words I have written reverse of this. That's all I have, whatever I have done here. It is very simple. So only one reverse operations I have done here. So one is one, 10 is written as a 01 reverse, 100 again it is reverse, 001, so 000, so it is reverse 000. So this is the simple thing here I have done. Okay, starting at the root node, it is the reverse of this, starting at the leaf node. Okay, this is the tree derivation. How to derive the tree derivation? In examination, they will ask you construct the Hoffman tree and derive the tree derivation of the two. So then you have to follow this procedure. Okay. So here also next one is if you want to find out the weight. Okay. So then we are going to write this weight order. Okay. So what I will do. So we have four characters. We have four characters. So that is why I will write 8 here. So maximum 8, 4, 2, 1. Okay, like that. So A, B, C, D, four characters are there. Okay. So for that I will write 8 here, 4, 2, 1. So like that. Okay. So weight order can be calculated as a like this. So D is 1. So D is 1, D1. So C1, D1, C1. Next. So 2C, 2B2. So 2B2 is nothing but the value of the C and D sum, that is 2. So that is why it is written as a 2B2. Next, 4A4. So 4 how you calculated that you have seen in the previous. Okay, 4A4. Next 8. So finally we have 8. So this is the weight calculation, weight order of the character set calculation. Okay, so this is about the static Hoffman coding and tree derivation. Okay.